Lesson 23 is on a few more identities. They are not as hard necessarily as the ones that we did yesterday. We did most of the identities yesterday, so hopefully you've had a chance to practice some of those items. But anyway, so we have a couple more identities. Some of these I will give you on a cheat sheet, some of them I will not. So if I star them, make sure you're memorizing them. So the first ones are the sum and difference formulas for sine and cosine. All right, so if I see sine of x plus y, it is actually equal to sine of x cosine of y plus cosine of x sine of y. Sine of x minus y is sine of x cosine of y minus cosine of x sine of y. And you might see these in books as alpha and beta or theta and alpha or something like that, but we'll use x's and y's. All right, cosine of x plus y is cosine x cosine y minus sine x sine y. And cosine of x minus y is cosine x cosine y plus sine x sine y. Okay, and these ones aren't too terrible to memorize. You don't necessarily need to know them for AP Calculus, but you will need to know them for this test. So memorize them. If you get stuck, then you can always think about maybe like sine of things that you do know. So maybe you do 30 plus 60. You're like, oh, I know that that's going to be sine of 90, which is 1. So then think, okay, is that sine of 30 cosine of 60 plus cosine of 30 sine of 60? And you can kind of go through those. So you can say, okay, sine of 30 is 1/2, cosine of 60 is 1/2. And then this one is square root of 3 over 2, square root of 3 over 2. So you end up getting 1/4 plus 3/4, and that does equal 1. So you can always kind of figure out what they are based on angles that you already know. But like I said, they aren't too hard to memorize. So why do we have these? So we don't always have unit circle values, and we need other formulas in order to find things like sine of 17 pi over 12 or cosine of 17 pi over 12. So for this first one, we're going to use the fact that 17 pi over 12 is 8 pi over 12 plus 9 pi over 12. And 8 pi over 12, if you divide by 4 on the top and bottom, you get 2 pi over 3. And 9 pi over 12, if you divide by 3 on the top and bottom, you get 3 pi over 4. So in order to find this, I'm going to do sine of 17 pi over 12 is really the same as the sine of the sum of 2 pi over 3 plus 3 pi over 4. So we use the sum formula right up here. Okay, so I guess I'll put stars next to all of these because you do need to memorize them. Okay, so I'm going to have sine of 2 pi over 3 cosine of 3 pi over 4 plus cosine of 2 pi over 3 sine of 3 pi over 4. And if you find each of these things, you know 2 pi over 3 is located right there. So it's going to be root 3 over 2. Cosine is negative root 2 over 2. Cosine of 2 pi over 3 is negative 1/2. And sine of 3 pi over 4 is root 2 over 2. So we get negative root 6 over 4 minus root 2 over 4. So negative root 6 minus root 2 all over 4. All right, and then the same idea for 17 pi over 12. So if you find 17 pi over 12 for cosine, then we're going to do cosine of, well, let me break it apart into the 2 pi over 3 and 3 pi over 4. So I'm going to have cosine of 2 pi over 3, 3 pi over 4. So that's the one where it's cosine, cosine minus sine, sine. So it's going to be cosine of 2 pi over 3, cosine of 3 pi over 4, and then the different signs, a minus, sine of 2 pi over 3, sine of 3 pi over 4. And if you find each of those things, cosine of 2 pi over 3 is negative 1/2. And then I have negative root 2 over 2 minus sine of 2 pi over 3 is root 3 over 2. And sine of 3 pi over 4 is root 2 over 2. So we get positive root 2 minus root 6 all over 4 when we combine them. Okay, so almost the same. And these are pretty common answers with the root 2s and root 6s for the sum and difference identities. Okay, so we have found exact values for those. So a lot of people, when you see sine of 17 pi over 12, they don't know what to do at all. So they just put it into their calculator and find a decimal value. So we're not finding the decimal values, we're actually finding the exact answer. All right, so this is the cosine of a difference. So this is where we do cosine, cosine plus sine, sine. So it's going to be cosine x, cosine of pi over 2, plus sine of x, sine of pi over 2. And we actually know what cosine of pi over 2 and sine of pi over 2 are because it's right here. That's the point 0, 1. So cosine of pi over 2 is 0. Sine of pi over 2 is 1. So we get 0 plus sine of x, which is just sine of x. So we've now shown something very similar to the co-function identity, but instead of being pi over 2 minus x, it's x minus pi over 2. And it's equal to sine of x. Okay, and the reason that works is because cosine is actually even. So cosine of negative pi over 2 plus x is the same as cosine of pi over 2 minus x. So that's why it doesn't matter if you have x minus pi over 2 or pi over 2 minus x, you actually get the same answer. So it has to do with the co-function. So that actually gives you another identity. Okay, so the next thing says prove that 2 cosine of x sine of y is equal to sine of x plus y minus sine of x minus y. So we're proving an identity, just like we did in the last section. So we're going to start with a more complicated side, which is sine of x plus y minus sine of x minus y. And we're going to break it apart. So we have the sine of a sum, so it's going to be sine cosine plus cosine sine. So I'm going to have sine of x cosine of y plus cosine of x sine of y. So that was the first part. And then I'm going to have minus, and maybe I'll write it over here. So minus the sign of a difference. So it's going to be sine cosine minus cosine sine. And you can flip back if you need to. Just know you'll have to memorize them briefly for the test. Okay, so then I'm going to have sine of x cosine of y plus cosine of x sine of y minus sine of x cosine of y, and then plus, when I distribute the negative, cosine of x sine of y. And I notice that some of it goes away, right? So I have sine of x cosine of y minus sine of x cosine of y, so it goes away. And then I have 2 of the cosine x sine of y, which is exactly what we wanted it to be. Okay, so we got our answer in the end. Okay, so just like sine and cosine, there are actually identities for tangent. These are ones that you will not have to memorize. Okay, but I'm going to show you how we get them. So if we want tangent of x plus y, what we're going to do is we're going to find sine of x plus y all over cosine of x plus y, right? Because sine of any angle, or tangent of any angle is sine of that angle over cosine of that angle. And we're going to break it apart. So we know that sine of x plus y is sine cosine plus cosine sine. Okay, so sine of x cosine of y plus cosine x sine of y. And then cosine of x plus y is cosine x cosine y minus sine of x sine of y. And we're going to do something a little bit strange. Okay, so in order to get what the book has as its identity, so what tangent of x plus y is equal to, we're going to divide the numerator and the denominator by cosine x cosine y in our room. Okay, and it's going to get a little bit messy, so you don't have to write this step, but you can watch it, and then I'll show you what the outcome is. So if we have sine of x cosine of y divided by cosine x cosine y, and then we have plus cosine x sine of y divided by cosine x sine of y, all over cosine x cosine y divided by cosine x cosine y minus sine of x sine of y divided by cosine x cosine y. Okay, so a little bit messy. All right, so I divided every single term by that cosine x cosine y. And when we do this, we'll box in all the x's, and then we'll box in all the y's for you. and you'll see that things will reduce out. So things like cosine x or cosine y goes away. Okay, so those are away. These are away. These are away. And these are away. Okay, so what we have is sine of x over cosine of x, which is tangent of x, plus, it didn't all go away. There's 1, right? So plus 1 over 1 minus tangent of x. Whoops, what did I do? This didn't go away. I knew that wasn't right. This one didn't go away, right? It's sine of y cosine of y. So that one becomes tangent of y. Okay, and that is the answer. So it's tangent of x plus, ooh, I still did something wrong. What did I do? Oh, this is cosine y. What am I doing? So tangent of x plus tangent of y over 1 minus tangent of x tangent of y. Okay, and that's the formula. I knew the formula. I just couldn't get there, man. All right, so so we'll fill those in. So if I have tangent of x plus y, it's tangent of x plus tangent of y all over 1 minus tangent of x times tangent of y. And tangent of x minus y is going to be tangent of x minus tangent of y all over 1 plus tangent of x tangent of y. Okay, so they're not hard formulas to memorize, but I'm not going to actually make you memorize those two. All right, so number 1 says write the expression as the sine, cosine, or tangent of an angle. So these ones are actually easy points on your math Excel. So when you see sine of 330, cosine of 30, plus cosine 330, sine of 30, we look back and we think, oh, what was that when we had sine, cosine, cosine, sine? Okay, and we add them together. So if you look back on your, on your cheat sheet here, not cheat sheet, you actually will need to know that. So sine, cosine, cosine, y, that's going to be the sine of a sum. Okay, so what we're going to do is we're going to take the sum of those two angles. So we're going to have the sine of 330 plus 30, which gives us the sine of 360. Okay, and that's what I want. So when I say the expression as the sine, cosine, or tangent of an angle, that's what I wanted, sine of some angle. Okay, if you want to find actually what that is, remember 330 degrees is here, so the sine value is 0. So you could do that as well. All right, tangent. So I have tangent of 120 minus tangent of 30. The one that had minus on the top was tangent of the difference, 120 minus 30. So this gives us tangent of 90. So that's what I'm looking for. If you want to find actually what that is, 90 degrees is here, it's 0, 1. So sine over cosine is 0, 1 over 0, which is undefined. So you could write it as undefined as well. Okay, so those, like I said, those ones are easy points on your math Excel. Okay, so a little bit harder. Maybe it says find all solutions of this equation. And it's like, man, this equation's hard. Well, if we simplify that left-hand side, it actually makes it a lot easier. So if I have sine of x plus pi over 6, it's going to be sine of x, sine of pi over 6. Oh, dang it, cosine of pi over 6. Plus, let me write it the way that I showed you in the notes. So cosine of x, sine of pi over 6. That's the first part. Minus sine of x, cosine of pi over 6. Minus cosine of x, sine of pi over 6. And that's all going to equal 1/2. So as you simplify, you're going to distribute the negative. And you'll see when you do that, that this part goes away. So let me make the plus and then plus. All right, and then the second part becomes 2 of the cosine of x sine of pi over 6's. Right? Well, what is sine of pi over 6? Sine of pi over 6 is 1/2. So I have 2 cosine of x times 1/2. So the 2 and the 1/2 end up going away. So we really just have the equation cosine of x equals 1/2, which we know how to solve, right? If we want cosine of x is equal to 1/2, we want on the interval 0 to 2 pi, so not all solutions, so not an infinite number of solutions, but just the solutions on 0 to 2 pi. So x ends up being pi over 3 and 5 pi over 3. So those are my two solutions. All right, so number 3 is another typical use of these sum and difference formulas. So if I see sine of 165, I need to think about angles that add to be 165 degrees. Okay, some of them, maybe I know 155 and 10 add to be 165. That is completely useless to me, though. 155 and 10 are not unit circle values, so I don't know what the sines and cosines of those are. So there's no point to using those. So I want to definitely use unit circle values. So when I see something ends with a 5, I usually think about 45 degrees. So in this case, if I do 45 plus 120, those are both unit circle values. So when I break it up, I'm going to have the sine of 45 cosine of 120 plus cosine of 45 sine of 120. All right, so when I find those, sine of 45 is square root of 2 over 2. Cosine of 120, if you think about where 120 is, oops, you're in the wrong spot. 120 degrees is 60 away from 180. It's right there. So it's going to be negative 1/2 is the cosine. So I'm going to have root 2 over 2 times negative 1/2 plus root 2 over 2 times root 3 over 2. So again, we're getting those root 2s and root 6s. Like I said, they're pretty common for these ones. So we get negative root 2 plus root 6 all over 4. You could also write it obviously as root 2 minus root 6 minus root 2 all over 4 if you wanted to. Okay, so if I have tangent of 13 pi over 12, these are the ones that always give my students problems. Okay, so if you think about 13 pi over 12, like I said, there's lots of things that can add to be 13 over 12. Like you could have 12 over 12 and 1 over 12, right? But pi over 12, we don't know what pi over 12 is on the unit circle. We don't know its values. You could find them, but then that would be very time consuming, right? So we don't want to use 1 pi and pi over 12. We want to go bigger. So then you start thinking, and usually if I break it up, I start thinking about things like this. So I'm like, okay, 13 is 1 and 12, but 13 is also 2 and 11. Well, 11 over 12, I don't know. So then I'm like, okay, well, what about 3 and 10? Well, I don't know 3 over, well, I do know 3 over 12, actually. So 3 pi over 12 and 10 pi over 12, those actually are unit circle values. It's pi over 4 and 5 pi over 6. So we can do those. So it may not be the same thing that your friends choose. It doesn't matter. You're going to get the same answer in the end. So you don't have to do exactly the same as everyone else. So we're going to do tangent of 13 pi over 12 is actually the same as tangent of pi over 4 plus 5 pi over 6. So you go through a couple of different options and you realize they don't work. They don't give you unit circle values until you find one that does work. So when this breaks apart, it's going to be tangent of pi over 4 plus tangent of 5 pi over 6 all over 1 minus tangent of pi over 4 tangent of 5 pi over 6. So tangent of pi over 4, since it's sine over cosine, it's root 2 over 2 divided by root 2 over 2, so it's 1. Tangent of 5 pi over 6, a little bit harder, it's right here. That's the one that's negative root 3 over 2 comma 1/2. So if you do 1/2 divided by negative root 3 over 2, you end up getting negative root 3 over 3. And you can check, you will get that. So we have 1 minus 1 times negative root 3 over 3. So we get the very messy 1 minus root 3 over 3 divided by 1 plus root 3 over 3. And I'm going to guess that MathXL will not accept this as an answer. I won't accept it on the test either. The thing that I don't like about this does not involve the square roots. The thing that I don't like is that there's a fraction within a fraction. So see how we have, like, it's called a complex fraction. So what we need to do is we need to multiply by 3 over 3. And this will make it much nicer because now I'm going to have 3 minus root 3, right, as I distribute in here and here, over 3 plus root 3. And I am totally fine with that answer, and I believe MathXL will be as well. You do not have to get rid of the square root on the denominator. At this point, we just don't care. So you can do it if you want to, but it's kind of like, you know, in Algebra 1, we wrote everything as mixed numbers. And then in Algebra 2, I told you to write them as improper. We're at that point. You know how to rationalize. You don't have to go the extra step. Okay, so the next one that we have is cosine of 15 degrees. Okay, so this is a pretty easy one to see. If you have 15 degrees, it's just 45 minus 30. So we have cosine of 45 minus 30. So it's going to be cosine, cosine plus sine, sine. So I'm going to have cosine of 45 cosine of 30 plus sine of 45 sine of 30. So I get root 2 over 2 times cosine of 30 degrees is root 3 over 2 plus root 2 over 2 sine of 30 degrees is 1/2. So we end up getting root 6 plus root 2 all over 2. Oh, not over 2, sorry, all over 4. I do that a lot. I always forget to multiply the denominator. So look back through and make sure I didn't do that on this video. You might get some bonus points. And then part D we actually did in example number 1, so we're going to skip that. Okay, and then the last little bit that we have is kind of a review of a previous section. So we're always kind of looping back with pre-calc and making sure that you remember all these different things. So we're talking about sine of alpha is equal to 3 over 5, and I tell you that alpha is an angle that's between 0 and pi over 2. So what that means is it's in the first quadrant. And then beta is an angle that's between pi over 2 and pi, so that means that it's in the second quadrant. Okay, so as I draw these, maybe I'll draw them off to the side over here. Let me draw first quadrant. I have alpha is in the first quadrant, and the sine of alpha is 3 over 5. So if you remember, it's the y value over the r value, opposite over hypotenuse. So if we want to find that other missing side, it's going to be a positive 4 because it's in the first quadrant. Okay, if I want to find beta, I know beta is in the second quadrant. So when I draw beta, I want to draw it in the second quadrant, and I know that the cosine of beta is negative 12 over 13. So that's adjacent over hypotenuse, or the x value over the r value. So if you find that missing side, you can do it with Pythagorean theorem. It's another special right triangle, or not special right triangle, but a Pythagorean triple, and you'll get a 5 there. Okay? It has to be a positive 5 because it's in the second quadrant, and the y value is positive. So when I'm asked to find something like cosine of alpha plus beta, I don't have to find what alpha and beta are. Okay, that's actually very, very complicated, and it will never give you the exact answer using your calculator. You're going to get a decimal approximation. We don't want decimals. We want the exact answers. So what we're going to do is we're going to break it into cosine alpha, cosine beta, cosine beta, minus sine alpha, sine beta. And since we have these lovely drawings, we can find each of those things. So cosine of alpha is going to be adjacent over hypotenuse. So I did adjacent over hypotenuse, so 4 over 5. And then cosine of beta is going to be adjacent over hypotenuse. So negative 12 over 13. Then I'm going to have minus sine of alpha. Well, that's going to be opposite over hypotenuse. So I'm going to have 3 over 5. And then sine of beta is going to be opposite over hypotenuse, 5 over 13. So when you multiply this all out, you have negative 48 over 65 minus 15 over 65. So you get negative 63 over 65. And the same thing for tangent of alpha plus beta. It's going to be tangent of alpha plus tangent of beta all over 1 minus tangent of alpha, tangent of beta. And you can find all of it. So tangent of alpha is opposite over adjacent. Tangent of beta is opposite over adjacent. 1 minus 3/4 times negative 5 over 12. Okay, and we get some different numbers here. So we're going to have, on the numerator, if you add those together, you get 1/3. On the denominator, you get 21 over 16. So you can find those if you want. So when you divide them out, you should get 16 over 63. It's your answer. You can use your calculator to help you if you need to. All right, so on the next page, we have what we call double angle identities, and these ones are going to be important to memorize as well. You will need to know these. So the double angle identities, they really just come from the sum and difference identities. So if you know the sum and difference ones and you have them down, which after you do them a few times on your homework, you're going to have them down, then you're good. You have them for the double angle then. Because sine of 2x is really sine of x plus x, which is going to be sine of x, sine of x. Oh, sorry, cosine of x, geez. So sine of x, I love how I just said you would have them down and then I wrote it wrong. All right, whatever. So we get that. So it ends up being 2 sine of x cosine of x. So that is what sine of 2x is. So double the angle in the middle ends up being 2 sine of x cosine of x. All right, now cosine of 2x, well, that's going to be cosine of x plus x. So that's the one that's cosine, cosine, minus sine, sine. So you end up getting cosine squared minus sine squared. Okay, but notice I have 3 different blanks here, or 3 different equal signs. So there are different ways to write this. So this is the one that I want you to know. The other ones you can always get, because you can think about cosine squared is really 1 minus sine squared. So if you replace cosine squared with 1 minus sine squared, you have 1 minus sine squared minus another sine squared. So when you do that, you end up getting 1 minus 2 sine squared x. And likewise, if you think of sine squared as being 1 minus cosine squared, then you end up getting cosine squared x minus 1 minus cosine squared x. So cosine squared x minus 1 plus another cosine squared x. So that works out to be 2 cosine squared x minus 1. So those are the 2 different versions, and they come from the Pythagorean identities. And then the last one is tangent of 2x. Well, that's going to be tangent of x plus x. So it works out to be tangent of x plus tangent of x all over 1 minus tangent of x times tangent of x. So the way we write it is 2 tangent of x all over 1 minus tangent squared x. And you might think 1 minus tangent squared x is equal to secant squared or something like that, but it's not. You can check, but it is not one of the Pythagorean identities. All right, so you don't have to memorize that one, but I would know these 2. All right, so number 1, so it says find all solutions of 2 cosine x plus sine of 2x equals 0 in the interval 0 to 2 pi. Okay, so when you notice that your equation has a double angle, so we have a 2x and we have an x, we notice that what we call the arguments are not the same. Okay, we can't solve an equation if our arguments aren't the same. So we need those things that we're taking the sine or cosine of to be the same angle. Okay, it's like we have a theta and we have another one is alpha. Like they aren't exactly the same. We need them to be the same. Okay, so what we're going to do is we're going to change our sine of 2x using our double angle formula. So I'm going to have 2 cosine of x plus 2 sine of x cosine of x equals 0. And I'm going to pull out the common factors. So they have a common factor of not only 2, but also a cosine of x. So when I do that, I have a 1 plus sine of x equals 0. So now I set these 2 pieces equal to 0. And hopefully you remember this from first semester with Maury. So we get cosine of x equals 0, and we get sine of x equals negative 1. So cosine is equal to 0 would be here and here, and sine is equal to negative 1 would be down here. So we get answers of, if we're on the interval 0 to 2 pi, we're going to have pi over 2 and 3 pi over 2. And then the sine of x equals negative 1 is just 3 pi over 2 again, so we just write it once. Okay? Okay, so I want to do another equation one. So we're going to change this to use a double angle formula to solve the equation. And let's make that y equal to 0. Okay, so let's do a little edit on this problem because I think it would be good to see how you solve something that has a double angle. So for this one, if you see that you have 0 equals 6 cosine squared x minus 3, we're going to pull out the common factor, which is 3. And we have 2 cosine squared x minus 1. So previously, we would have no way of solving this. We don't know how to factor 2 cosine squared x minus 1. So we would be stuck. We would have no idea how to solve this. Well, I guess you could like set it equal to 0 and take the square root, whatever. All right, so anyway, there is another way that we can solve this. So if I have 2 cosine squared x minus 1, I know that that is equal to cosine of 2x. It was one of those different forms. So in other words, we have cosine of 2x has to equal 0 because the 3 is doing nothing. I can divide the 3 over. So what we do if we're trying to solve something where we have 2x is we can let w equal 2x. Okay, so we have cosine of w equals 0. But now instead of finding it on the interval 0 to 2 pi, since I have 2x, I want to find on 0 to 4 pi. I want to double my period, or double my interval. Okay, so when I solve for w, I'm like, okay, cosine is equal to 0. Well, that happens here and here. W, like we just had, was pi over 2 and 3 pi over 2. But if I'm finding all the solutions on 0 to 4 pi, I'm also going to have 5 pi over 2, right, adding 2 pi to pi over 2. And I'm going to have 3 pi over 2 plus 4 pi over 2, 7 pi over 2. Okay? Because I know 2x is equal to all of those things. And if I want to solve for x, I'm then going to divide by 2, which means that my answers are all going to be on, instead of 0 to 4 pi, they're now going to be on 0 to 2 pi like I want. So I'm going to have pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, so nothing is bigger than 2 pi. Those are my 4 solutions. Okay, so kind of tricky. When we divide by 2, all of those answers now are on 0 to 2 pi. Okay, so that's why I wanted to change that example. I wanted to do one where we solved an equation with 2x. And the same is true for, like, if you had 3x or something, you know, you would just do, instead of 0 to 2 pi, you do 0 to 6 pi. All right, and then the last formulas I will definitely give you. You do not have to memorize these. So don't memorize. Okay, and these basically come from, like, the double angle formula for cosine of 2x. If you replace 2x with, like, w, then that means x would be, well, I guess maybe that's not what I want. Okay, if I want to solve for sine of x from that, I could solve and get this. Okay, so we're just rearranging a formula that we already know. Okay, and they come from those different cosine equations. All right, so those ones aren't super important, but the power reducing formulas actually give us the half angle identities, which can be a little bit important. So I'll show you the half angle. Again, you don't need to memorize these ones either. All right, so if I have sine squared of x over 2, so if I replace with x over 2 here, that means when I have 2x, I'm going to have 2 times x over 2, which is just my x. So I'm going to have 1 minus cosine of x all over 2. So if I want to solve for sine of x over 2, I take the square root of both sides. And whenever I take a square root, I do plus or minus. This is where the half angle identity comes from. It comes from that power reducing formula. Okay, but the big thing to remember is that you have to decide what sign you have. So if you have a plus or minus, you need to decide if it's plus or if it's minus. So an example would be if I have sine of 15 degrees, I could do plus or minus the square root of 1 minus cosine of 30 all over 2. But I know that 15 degrees is in the first quadrant. So the sign of it has to be positive. Okay, so it's going to be the plus one. And you would continue the problem, and you'd be like, okay, well, I have 1 minus cosine of 30. Cosine of 30 is square root of 3 over 2, all over 2. I would multiply by a 2 over 2 on top and bottom. So you're going to end up getting the square root of 2 minus root 3 all over 4, and take the square root of the top and the bottom, so you get that. So the thing that's really, really weird about the half angle identities is you get an answer that has what we call a nested root. Okay, so you have the square root of 2 minus the square root of 3. And if you find that decimal approximation, let me go ahead and do it. So if I find that, I get 2 minus the square root of 3 all over 2. I get 0.2588. Okay, but we know that if we did sine of 15 degrees, there's another way we could find that. We could do the sine of 45 minus 30, which we learned in today's lesson, right? So you could say sine of 45 cosine of 30 minus cosine of 45 sine of 30. And we get a different form of the answer. We get root 2 over 2. Cosine of 30 is root 3 over 2. Root 2 over 2. Sine of 30 is 1/2. So we end up getting root 6 minus root 2 all over 2. And we think that those answers aren't the same because they look nothing like each other. One has a square root within a square root. But if you do this on your calculator, oops, I did divide it by 2. I told you I always do that. Over 4, right? And I divide by 4. I actually get exactly the same number. I get 0.2 588, and so on. Okay, so they're actually equivalent. And when you do your Math Excel, you want to be very careful. You want to do whatever it's telling you to do. So if it says with a half angle identity, or if it says with the sum and difference formulas, you want to do that way because they're not going to accept the other answer. So be really, really careful in your Math Excel. So I just wanted to point that out before I go on to these examples. Okay, so when it says find the exact value of the following, so let's say it said using the half angle formula. Okay, well this means that I would have tangent of 7 pi over 12 is half of 7 pi over 6, which is a unit circle value. Okay, so when I do my tangent, did I write my half angle for my tangent? There's 3 different forms for the tangent. So I can do this one, or this one. It doesn't matter. Okay, I'm going to do the first one, 1 minus cosine of x over sine of x. So x is my 7 pi over 6. So I'm going to have 1 minus cosine of 7 pi over 6 over sine of 7 pi over 6. So this was the x over 2, and this is the x. Okay, does that kind of make sense? So if I talk about 7 pi over 6, 7 pi over 6 is just a little bit past 180 degrees. So it's going to be the one where its cosine is negative root 3 over 2, and sine is negative 1/2. So I get 1 plus root 3 over 2 all over 2. Oh, not all over 2, all over negative 1/2. And I'm going to multiply by negative 2 on the top and the bottom. So when you do that, you get an answer of negative 2 minus root 3. And that's it. Okay, so the same idea for sine of 5 pi over 12. So if you look at your half angle, this is one that involves a plus or minus. So we're going to need to think about the quadrant. So it's going to be plus or minus. I'm looking right here. Plus or minus the square root of 1 minus cosine of x all over 2. So the question is, what's x? Well, this is my x over 2, right? So my x is 5 pi over 6. Because when I divide it by 2, I get the 5 pi over 12. Okay? And I decide what quadrant I'm in. So if I have 5 pi over 12, it's not quite 6 pi over 12. 6 pi over 12 would be right here. It'd be a pi over 2. So we're in the first quadrant. So if I'm in the first quadrant, I decide for my sine value would be positive. So I circle the plus. So I have positive 1 minus cosine of 5 pi over 6. When we think about 5 pi over 6, it's right here. So it's negative root 3 over 2 all over 2. So I get the square root of 1 plus root 3 over 2 all over 2. So I'm going to multiply by 2 on the top and bottom. So I get 2 minus root 3 all over 4, and I take that square root into the top and the bottom, so I get the square root of 2 minus root 3 all over 2. That's how I would write my answer. Okay, so a little bit tricky and kind of a strange form. We can talk about how to, if you're really interested on how to unnest a square root, but it's been a while since I've done that, so I'll have to look it up. There is like a formula to do that. You could also probably Google it too. Okay, so the next one. So if I have tangent of x equals negative 5 over 8, and I know that x is in the, let's see, fourth quadrant. Okay, it says find tangent of x over 2. So let's first draw it. We know that tangent is opposite over adjacent. So my adjacent is going to be 8. My opposite has to be the negative 5 because we're in the fourth quadrant. I'm probably going to need to find that other value. So if I do 8 squared plus negative 5 squared, all under a square root. Oops, screw up the plus. So 64 plus 25 under square root, so we get the square root of 89. So if we talk about tangent of x over 2, we'll use that first formula, which was 1 minus cosine of x all over sine of x, which is 1 minus cosine of x is negative 5 over oh wait, no, -5, because sine is adjacent over hypotenuse, so 8 over square root of 89. And then sine is -5 over the square root of 89. So we're going to multiply by the square root of 89. And I'm going to do negative as well, just because I don't like that -5 on the bottom. So your final answer ends up being negative square root of 89 plus 8 all over 5. Let me make sure. Yep, okay. So it says you will be expected to memorize all trig identity formulas, except for the power reducing and the half angle identities. And then a couple of those tangent ones I didn't have you memorize as well. So remember, you can find most things using the sum and difference formulas. Don't make things harder than they are. So don't try to memorize every single thing without kind of thinking about why they are true. So remember, you can always think about like sine of 30 plus 60 if you're trying to get sine of 90. So don't like mess up all 4 formulas just because you were trying to memorize and you weren't thinking about why they're true. Okay, so good luck on the homework. I don't think it's as bad as last night's homework, but if you need help, once again, come to the office hours. Thanks.